Thanks for tuning in to Stay Sharp with Razorleaf, your secret weapon for all things digital and manufacturing. In today's episode, Jonathan Scott and Jen Farello take on the challenge of unpacking the many buzzwords that roam about in software today. From digital transformation, digital twins, digital thread, and all those spin-out concepts, to AI, blockchain, and IDEs, the tag team duo wind their way through the vernacular of digital technology. And now let's listen in with Jonathan and Jen.
All right, welcome to the podcast. Hey, everybody. We're back and still talking about digital stuff, right? Products, manufacturing, what do people make? And this week, I'm pretty excited because the topic's a little freeform. We want to talk about buzzwords in the industry. There are so many buzzwords and they're so much fun. Some of them are just really ludicrous, but lots of them have interesting meaning. And that's what I'm hoping we can get into today, Jen. I want to talk about some of the buzzwords, the ones that we hear about all the time. And what do we think they mean? Are they real? do they mean anything meaningful? That kind of thing. So I'm hoping we could throw a few out and chat about them. But I'm excited about the topic.
Well, I am too. And I think if you're going to start with buzzwords, you got to start with the elephant in the room, right? You got to start with the apex of it, digital transformation.
The big one? Yeah.
The big one. Digital transformation. That's a huge one. Like what all in your estimation, what all does that encompass?
It is. It's a great umbrella because it's, it can cover anything. That's the beauty of it.
And all things.
I mean, what I hear when I hear people talk about it and I ask, what's that supposed to mean? Well, there's the digital part. That part is pretty easy. Oh, yeah, we're getting to digital ones and zeros, data in that form. And then the transformation part. Well, everybody says, well, that one's obvious too, right? It's about changing things in a big way. Okay. But I do think people mean something unique when they put the two together. And I hear folks, I'm going to paraphrase the definitions I've heard. It's about transforming, changing business models, doing things like really differently because you're doing them digitally. Not, oh yeah, we had our process yesterday on paper and today we're doing it in a computer because they're electronic documents and we route it through the same people and maybe it's a little faster because it's using a computer. But it's, oh, I could not have offered my scooter as a service unless I could do things digitally, unless I could put an app on your phone and you could rent it and, use it for an hour and pay me through an electronic means and then leave it there and it notifies somebody it needs to be charged for the next person to come and use it. That I'm just making one up, but that was a digital transformation. You couldn't have done that unless you were doing things digitally. So I think that's what it means. What do you hear?
No, I agree with that. And you're right. It's actually as much as a transformation, it's a reimagining of what's possible based on the fact that so much of, whether it's manufacturing processes or the way we track the data, et cetera, so much of it is digital now rather than on paper or in people's heads. So yeah, I think it's a reimagining.
It's letting you do something new and different that you couldn't have done another way.
Exactly.
Right?
Exactly. It's not just faster. It's different. It's better.
Yeah, it sounds like we're on the same page about what digital transformation really means, but of course it can mean a lot of things. I've got another one. While we're on that digital word, here's a couple that maybe they are all the same or they're all related enough, but digital thread, that's a fun one. Digital web and digital fabric. I hear those not as much, but I hear those in the same breath as digital thread. What about from your perspective, Jen? Do you hear those at the same time? And what do you think they mean?
Definitely hear them at the same time. And they almost seem like an expansion. Each seems like an expansion of the other. So digital thread was first, right? That's the first one that came across. And that's just the winding of data throughout the product lifecycle. Then as you, at least from my perspective, as you move from PLM to other systems, it felt less like a thread and more like outsheets, more like a web. Okay, you're going from your PLM system to ERP system to MES, et cetera. So you're creating more of an expansion of that. And then as you're getting data throughout those different systems and they're talking to one another, you're starting to actually weave a digital fabric. So that's the way it makes perfect sense to me. I don't know. What are your thoughts?
I feel like I've heard that too. And the web and the fabric to me, those always got brought up as a way of trying to expand the digital thread concept, a lot like what you just said. People think of the digital thread as all the information related to a product over its life, from the early ideas to the actual design to, the documents, to everything about it, tying all of the product data together. It sounds a lot like PLM, right? But then folks would say, well, but it's more than just PLM. That's the intent of the concept. So they would talk about decisions, right? And events and things that happen that are part of that digital thread. And that's where I've heard a lot of people get into. So it's more like a web because it goes in different directions. It's not all linear. It's not all along the product lifecycle kind of thing. So I agree. I heard the first time I heard digital fabric, I heard another way of thinking about that point, that it's multidimensional. And it was saying, well, if a digital thread runs one direction, and that's about the product, and it's kind of, maybe there are a lot of digital threads running in parallel, then what weaves across that perpendicular to it, going the other direction, that would make a fabric, is the manufacturing data. And I thought, well, that's interesting. But it's just another way of saying the same thing. It was pointing out that from the perspective of the plant or factory where you make a product or make multiple products, it runs across it. So a product goes through multiple stages in a factory, but if you sat on the machine and watched, you'd see many products coming through it. So that thread runs across your station. But if you look in the factory from station to station to station, it's like a perpendicular thread. What's that data? What does it look like? How does it impact all of the different products? And I thought, okay, I think I get it. It's the same theme though, right? Which is, from this concept, you've got multiple vectors or dimensions to it. So I think they're all in the same ballpark, talking about the same concept.
Right. Just the question listening to you talk, the question comes up to me anyways. Digital sewing machine, is that next? What's going to bring this all together?
What is a digital sewing machine, right?
I'm sure there's one out there.
Can you pump out a thread to tie things together? My digital dress doesn't fit. I need to have it tailored.
Bet we could make a lot of money with that.
Yeah, no doubt. I've got another one. What do you think? Because to me, these connect logically in my mind. But what do you think about MBE, model-based enterprise?
Well, again, that was an evolution of an earlier term, right? MBD, model-based definition, model-based, and then MBE was also model-based engineering.
Right. But you're right. What started as a small concept, I shouldn't say small, but I mean a specific concept with model-based definition of, hey, I don't need to have a 2D drawing if I can put lots of information in the model and I can fully define what I'm trying to make in just the model. Okay. Right. I mean, it's a targeted concept. And then it turns into this bigger thing when you say, well, wait a minute. If I could put everything into some sort of descriptive model that's based on data or contains a lot of data, and I could share that with other people and use it across the different groups, and manufacturing could read that MBD, then I start to build out some kind of model-based enterprise. Yeah.
No, I agree. Matter of fact, I would go so far as to say that MBD might have been the beginning of the digital thread, right? Because you just had a CAD model and you had a corresponding drawing, and that you ran off one or the other. And by putting all of the annotations and the manufacturing data, et cetera, into the model-based definition of the CAD product, or putting all that information in there, it allowed you to just access that and pull that, rather than working off what's the word I'm looking for? A derivative.
Right. Sort of a dead end, right?
Right.
It lets you start to have a more continuous thread. I think that's interesting because I want to dig into it for a minute.
Okay.
The digital thread, I think you can have without being model-based. I think there are lots of people who might have pieces of data, and they might even have artifacts that are documents or drawings or things like that they can still tie together to make a digital thread. I think digital threads get even more interesting when they become model-based because they're much stronger. To your point, if you could take let's take an example, a feature in a CAD model that has certain characteristics to it, certain dimensions, tolerances, whatever it is, and then you can go create a manufacturing model that ties right to those features and characteristics as data, right? So it's like it's referencing that data. And then you have a quality model that ties to that manufacturing and that engineering definition, that model, right to those features and characteristics and that data. That tie is so much stronger than saying, oh, well, this drawing goes with that model, this PDF spec goes with that CAD model or that bill of material entry. You know, if you really get deep into the models and tie them together, it's a much stronger thread, I think, that you're building.
Well, absolutely. And it's, getting again back to MBE, the model-based enterprise, if all of that data is digital, it's all together, then if you make one change in that CAD feature, that then it can propagate all the way down so that you're not going, well, wait, is this the latest drawing or is that a newer part? If it's all in the same model, then it just flows downstream naturally.
That's right. That idea in the enterprise of a shared model, right, which is what MBE in theory is about, lets you have that kind of upstream and downstream change happen in an automated way instead of to your point, like lots of questions about, well, what changed? What's the latest? What's the most recent? Are they really related? That kind of thing. So I think it's fun that we could at least tie those two together. And there's probably a bunch of other MB whatever acronyms like you just said. MBE, is it big E or little e? And does it mean engineering or enterprise? And what does that mean? And I've heard of all kinds of them, right? Model-based quality, model-based definition.
And the one that we talk about periodically, model-based systems engineering.
Ooh, I love it.
I know it's one of your favorites. So
it is. It's one of my favorites, right? And it's amazing to me how many times we talk about the buzzword of MBE, and then somebody immediately is like, yeah, because, in model-based systems engineering, and I'm like, those are different, right? They're two different things. And we don't need to figure that out on this podcast, but I think it's really important to talk about all of the different MB whatevers and what do they mean and how do they fit into that umbrella of MBE?
Well, but I think we're talking about buzzwords. I think it's a good idea. Tell me the difference between MBE and MBSE.
Sure. I'll throw you my quick thoughts on it. For me, systems engineering is a certain discipline or domain. And systems engineers have to look at problems and they solve problems from a very specific view. I say it's a very specific view. It's a specific way of looking at it, but from a very broad view. And model-based systems engineering is doing the work that systems engineers do using models rather than using documents. And I know that sounds overly simplistic, but it's probably not even descriptive enough to really get my point home. But when I look at it, I think about the software tools that do MBSE. They are containing lots of data and relationships between the structure of a system, the behavior of a system, and the requirements of a system. And it's linking all those in the way that like CAD models, mechanical or electrical CAD models did when they linked components together with assemblies or with the geometry or the function. MBSE is doing the same sort of thing inside of a data-based file so that you can have all kinds of different views of that system's model in diagrams, in reports, in whatever. But MBSE is specific to that discipline. So much like MBD goes with mechanical, MBSE goes with systems engineering. And so it's not the overarching MBE enterprise, right? It's a component of it. It's an element of it. And you need to string a bunch of those things like MBSE and MBD together to really have a full MBE. Yeah, exactly. That's how I think they're different.
Oh, it makes sense. It makes a lot of sense. So when you're creating different models, creating different systems, pulling them all together, what's your end goal, right? Your end goal is a digital twin?
So talking about all those models, I think it gets us to another buzzword that's fun, which is digital twin. Because I don't think you can really have a digital twin, my understanding of what it is, without lots of models. So there are some other terms we ought to talk about here because I hear lots of folks having fun debates about, well, is that really a digital twin or not? But first, I'll tell you what I think it is, Jen. I'm interested to hear what you have to say. I think a digital twin is really a model. Dun, dun, dun. I just think it's some level of complexity in a model that makes people say, wow, that really represents the thing I'm interested in, the physical entity, in such a complete way that I would call it a twin. But at its core, that's what it is. It's a really good model of the thing for whatever purpose you have in mind. If I'm trying to predict when it's going to fail, it's a great model to help you understand that. And where it rises to the level of needing a new term is, I think it's novel and unique in terms of what we've seen in the past and what we can do now with the kind of data we have in these models. I'll give an example. I've got a simulation model of some component that's so good that if I feed it with data that's coming from the field about how that thing behaves in real life, and I sort of simulate how it's behaved over the last, 2 years, that now I can accurately predict when it needs to be maintained, when I need to, replace it, or when look for cracks or whatever, because it's now the model's so good, it can help me predict something like that. So now it's no longer just like, oh, it's not a simulation model. Now it's really a twin.
Yeah, but is it at that point where you're going that far to be able to predict, maintenance, et cetera, failure? Is it gone beyond digital twin? Is it now, it's a virtual twin?
Well, I hear that term too. I'll tell you where I think those fit. I think it's sort of the opposite of what you just said. From my perspective, when people start to have a debate about, well, when is it really a digital twin versus something else? I think it's fair to say digital twin is of a particular physical instance. So, let's say I'm going to make 10 of these things, 10 helicopters. I'm going to have a digital twin for each of the 10 helicopters. So I'll have 10 digital twins. Before I built the first helicopter, all those models that made up the design that I was going to make, those are a virtual twin of the family of 10 helicopters. So I like the term, but I think that's how I would differentiate. And I'll say before we get off that topic, there's another term I've heard folks use that I think is very useful, and that's cyber asset. This comes up a lot in the DoD context, where I
was going to say that's a new one for me. So
okay.
So I'm interested to see what you.
Yeah, the defense folks are saying, look, I have a contract to buy a physical asset, or my helicopter example. I'm buying 10 physical assets, and I'm also buying 10 cyber assets, right? So in that case, they're saying it's a digital twin of the physical thing. So I think of digital twin and cyber asset as almost the same meaning. The cyber asset has all of the as-builts, how is it designed, how is it built, and the as-builts, of course, are unique to each of those 10 helicopters. So there's one for every helicopter. And I think the virtual twin represents the concept before anything was built. Or I shouldn't say the concept. It represents the design. It's the twin of it, but it's I was going to say digital twin. That's no good. It's the twin of it, but before anything is real, before you have any physical instances. So I don't know if I'm right about that. I don't know if there is any right on any of these things where it's a buzzword and it's new, right? But I think you start with a virtual twin. When you start making them, you have a digital twin of each physical instance you make, and that is also a cyber asset.
All right. Well, that seems pretty clear, at least between you and I.
So far, anyway.
I was glad you did that summary, because I was feeling like we'd been going like
circles, yeah.
Yeah, circles, definitely. We're talking about creating these digital twins, creating, manufacturing, et cetera. How do those fit into, I'm going to throw another buzzword at you, Industry 4.0 or smart factory?
Yeah. I think it'll be hard to talk about these without getting into something else. And maybe we should come back to that. But the term I'll throw out when I think of those is IIoT, Industrial Internet of Things. And of course, that means you have to talk a little bit about Internet of Things. And let's come back to those. But the gist to me is it's about data, having data in manufacturing, in the factory, that you can use to be smarter, right? Smart factory is a good one that we hear about. But it's about collecting data and using data on the shop floor to make manufacturing behave differently than it ever has, right? And I think that goes right into what we were just talking about with cyber asset, right? You can have a cyber asset if, as you're building the helicopter, you record everything on paper and then you make it digital at the end. Okay, you can. But the way to really get there, the modern way to get there, is with this Industry 4.0 sort of look at things, is that you're doing things based on a model, but then the work that you do, you're also collecting digitally and you're leveraging it digitally. You're watching your processes and you're doing things like statistical process control. Oh, I'm getting out of line. Well, then adjust the machine automatically based on, oh, it's moving out of tolerance band. Let me tweak it and readjust it back to where it needs to be in band. And the whole time recording all that data that says, well, when helicopter 7 came through, this is how the machine was performing. Therefore, its cyber asset has data coming from the smart factory about how it was built. What were the conditions when it was built? And all of that rich data is what contributes to the value, the richness of the cyber asset and its digital twin that's going to help you predict how helicopter 7 might behave differently in the field than helicopter 6 because the machines were behaving differently when it was built. So, boy, tying a bunch of these buzzwords together, but I think that to me is what Industry 4.0 is about, is it's about leveraging data and models and new capabilities in a way that enriches our understanding and the way that we build things. I don't know. What do you see? I'm off on a tangent.
No, I know. I no, I agree. It's the amount of data that's out there, and the fact that we're capturing it now and measuring it and responding to it allows us to modify the way we're doing things like in real time. And I think that's very much what Smart Factory is, or what digital manufacturing is focused on accomplishing, is basically automation, right? Automation of the manufacturing process, whether it's optimizing the machines, optimizing the environment that the product is created in, or tracking back to, hey, we created these, whether it was helicopter 6 or 7, what, they were made on the same day. And helicopter 7 is showing some wear in these particular areas based on the machining that it was going through that day. We should take out 6 and see if it's got some of the same issues before it starts showing up in the field.
Absolutely. And I think it's, to me, the Industry 4.0 part is all about leveraging the data somehow. And you might leverage it in a bunch of different ways, right? It might be as simple as analytics for trending, like we talked about, or it might be some of the other buzzwords we've already talked to, like model-based. That can have data also, but it's like, how do I feed a machine based on a model instead of putting a human in the middle? Like, those are all Industry 4.0 concepts, in my mind anyway. Do you differentiate them at all? Is there anything that you would say like, well, that's part of Smart Factory, but that's not really an Industry 4.0, or vice versa, or digital manufacturing?
I would say, to me anyway, digital manufacturing is the umbrella term. That's what holds, whether it's Industry 4.0 or Smart Factory, IoT, like basically they're all pieces of digital manufacturing. Digital manufacturing enables digital transformation, to bring us back to the beginning. So a Smart Factory to me is the instantiation of digital manufacturing. It's the shop floor, and how all of the machines interact, et cetera, how the manufacturing processes feed into one another and the data that they capture there. Industry 4.0 is just bigger than that. It's what can we do with a Smart Factory? How far can we go with that?
So it's a little bit of a drill down, right? Industry 4.0 is kind of the broadest one. And then if you look beneath that, you would see the Smart Factory, which is, connected and using data. And then below that, digital manufacturing is, it's a more specific term even inside of that. And it probably relates to other things. Actually, you know what? I want to dig into another buzzword that I bet is related to digital manufacturing in your mind, at least it is in mine. And that's, what about additive manufacturing? It feels like we couldn't do that today. Like whatever, we can talk about what that means. We should define it, but we couldn't do it without being digital. I don't know. What do you see?
Oh, no, we definitely could not. I spent a little bit of time in my career at both 3D Systems and HP in the additive space. And Smart Factory is very closely related to additive manufacturing, because what we were finding as we were developing software to run the machines is that it wasn't just like the software didn't have to just do all of the manipulation, get the data ready to be consumed by a 3D printer, but it was all about how you were scheduling the jobs and how you were running all of that. So, matter of fact, that at HP, they had an HP Smart Factory, right? So it's, it really comes together. But yeah, I mean, it's all of that it's all run off of digital data. I don't think you have 3D printing without that, right?
So you just clarified something, I think, for me on back to digital manufacturing and smart factory, right? You can do digital manufacturing like additive manufacturing on a specific machine, a specific process. That could be digital manufacturing. When you start stringing them together and you look at the throughput of the whole plant and how they operate together and how the data might flow between them and be used across them, now you're talking about a smart factory because it's not just one process or operation. It's all of them collected together to make a product and not just a component.
Right. And I would say, I mean, like I said, it's with additive manufacturing, with traditional manufacturing, technically speaking, none of the data needs to be digital. Of course, now all of it is.
Right.
But you can take a block of metal and you can machine it.
Yep.
You can do that by hand. That's where we all started, right? But additive manufacturing requires STL. It requires a digital format. So you can't have one without the other.
Well, I could think of one. My kid's got this little pen. I can't remember what the thing was called, but it's this additive pen where plastic comes out of the tip and they can write their name with it. Yeah. But I can tell you that's not repeatable and you're not making cars with it.
Right. Now we're back to what's a manufacturing organization.
That's right. But it brings up a lot of interesting points, I think, about additive that I'm going to just go on a tangent for a minute because I think additive is a lot of fun, especially as it relates to PLM and processes and life cycle and things like that. The one that I love talking about is the mind blower that is, hey, in engineering, before additive, you had this assumption that if I could tell you the geometry of something and I could tell you the material it was made from, you had everything you needed to know, right? I mean, that's enough of a specification to go make one. But now with additive, because the material is no longer homogeneous and it depends on how you laid it down and how long it took you and the cooling, what are the thermal properties? Is there spring back to it? Is there pre-stress in it? You've now entered the realm of material isn't homogeneous. It depends on how you made it. The process dictates what product you get out on the backside, right? So before when you said, oh, it's aluminum 6061 T6, that's what it was. It's homogeneous. You cut out of a block of that, you know what you got. But if you use aluminum in a particular, formulation of aluminum, but you lay it down in a different way and you speed up the machine here and you slow it down over there and you heat treat this area and you don't that and all that stuff, the part comes out differently. So, our world is upside down in an engineering perspective because of things like additive. That's why it's such a buzzword, I think. Well, lots of reasons, but that's one of them.
Right. And it's funny because, so two things occur to me. What's exciting also about additive is the fact that it can create shapes that can't be traditionally machined.
Right.
Right. So that, again, turns design on its head, because then you're free to design more based on parameters and boundary conditions, things like that, rather than, well, I have to design it this way because I can't put a hole there.
Right.
I can't get to that. Well, you can if you create it from an additive perspective.
Which is fascinating because the whole DFM, right, design for manufacturing, that was very popular years ago. Like, hey, you can optimize your product if you think about other areas, like design it based on how you can manufacture it. That just got really hard. It got really easy and really hard at the same time. It's like, well, you can make all kinds of things. But then it's like, well, what couldn't I make? How do I design it for manufacturing, now that I've got twice as many processes since I have additive and subtractive?
Well, and see, that again is why additive manufacturing and smart factory are so closely tied as well, is because, additive has been around since, 1950s, 1960s? I'll have to look that up. In any case, Chuck Hall was just awarded a Presidential Medal of Honor. I saw that for the creation of STL. But it's been around for a really long time, but it hasn't yet reached full production. And part of the challenges of that is because of it needs a smart factory. It needs to do that at scale. And to do that at scale, you need to have all the different components of a smart factory. You need somebody to control that workflow.
That's right. And there's an interesting element of that to me leads to another topic. So I'm going to make a segue here, but
Okay.
it takes a bridge, right? This isn't a natural one. But so if you are making something additively and you have to have digital information to do it, it raises this notion of, well, if you have the same 3D printer, I'll just, try and put it in basic terms, at the other end of your digital pipe, then all you need is to transmit the STL, the part, the definition of what do you need to print. And then people in totally different places could make exactly the same part, right? That is way different than the factories we're used to, where it's like, well, you have to make it here, you make it here in a certain way. So the idea, like, I've heard about this plenty in Navy circles of like, well, I put a 3D printer on a ship and I don't have to carry spare parts. I'll just print the spare parts I need. Great, that's super cool. But it raises some other challenges of if I've got the best 3D printer in the world, and then I could get a hold of all the models that I wanted to print, what stops me from printing anything that I need instead of going back and buying it from the person whose intellectual property it was when they designed the part in the first place? So, big questions about rights and digital rights and things like that. But, so now I'm on to my next buzzword, distributed ledger and blockchain, right? Because this is an interesting answer I've seen people offer to that problem of, well, wouldn't it be great if I could just print a part anytime I needed it? Sure. But once I've given you that file, you could print 1 million of them, right? And maybe what I want to do as a manufacturer, the person who made back to the helicopter, who made the helicopter originally, and you want to print a spare part for it, what I'd like to do is sell you 10 prints of that part, that spare part you need, for $100. But after 10, you can't have it anymore. You got to buy another 10 from me, or whatever it is, right? But some kind of rule or smart contract. There's another buzzword that goes with this. But that's what distributed ledger is about in my mind. So let me just define it quickly. So the distributed part is it's saying that the record of something that's happened, whether it's a contract or a model or maybe a transaction, that is recorded a bunch of different places, right? So that's the ledger part, is whatever you're recording, but it's distributed, meaning I've got a copy, you've got a copy, there's a copy in China, there's a copy in, Germany, all over the place, so that if there's any question about it, those independent copies all know exactly what happened. And also, by the way, those are, they're encrypted or protected some way so that nobody can monkey with them. And that's the important idea here, is that these smart contracts, or, in the case of blockchain and cryptocurrency and things like that, money, that they're protected, they're immutable. No one can argue like, oh, wait, that's not really what happened, or nobody can change it or corrupt the information. And of course, that's really critical when you think about anybody could print it anywhere, but if I can control how many times they can print it, make sure that they've got the data they need to print it, but they can only use that data once, those kinds of things, that's what can enable some of those capabilities. So that's why I was connecting that back to additive manufacturing, is I think, yeah.
You're right. That makes a lot of sense. And that's one of the things we used to talk about all the time, is partnering with different companies to allow that protection of intellectual property.
Yep. I think there's another place where it shows up as we're talking about smart factory, and that is, I don't know if this is a buzzword or not, but I've heard people use it talking about that blockchain concept and how it can fit in with manufacturing, is digital provenance. Where did my part come from? What happened to it over its life, right? And this comes back to cyber asset we were talking about earlier. So if I take a block of metal and I say, okay, the forge that it came from says that this is the chemistry of that metal and the heat treat that it went through, great, it's good to know. If I could record that in a digital ledger that says that the person I sold it to then can pick it up and say, and you know what I did with it? Then I cut it into this shape. Okay, great. If I could record that on the digital ledger, fantastic. Now I know that part started with this chemistry, had these operations done to it to make that geometry. And now a third person coded it. And I used this chemistry to put this coating on it, and this is now how it behaves. And I record that on the digital ledger that ties to that part. That digital provenance is now recorded in the digital ledger, and anybody who has access to know that later or find that information later, because it was put in a blockchain and protected and federated and blah, 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 they can have confidence in it, that it's right. Nobody forged the records. They couldn't forge the records. So there's lots of applications, I think, where that could come up. And it's a fun one. I haven't heard a lot about it lately, but it's an interesting concept.
Seems like it'd be particularly interesting and relevant in aerospace.
Mm-hmm.
When you're, and probably a lot of defense as well.
Med device.
Med device, that's a good one.
Anything where it's really life and safety and health and those kinds of things that you care about. You really want to make sure that you don't have counterfeit parts, and you want to know where it came from, and traceability back if there is a problem to run it to ground and figure out how big the problem is. So,
well, and that traceability is particularly important. Again, like touching on additive, right? Because you're creating a lot of times a lot of parts at the same time under the same conditions. So if there's a failure at any point, you want to say, okay, wait, what batch did that come from? Are any of those other parts, particularly ones that attach engines to planes, things like that, do we need to check all of those out because they were manufactured under the same exact conditions?
So I think that buzzword has got a lot of promise. I haven't seen it all show up yet, but it's got a future, right?
Without a doubt.
All right, here's a big one. While we're talking about tech and fun tech that maybe isn't just specific to the manufacturing and maker kind of space that we talk about on this podcast, but what about AI, artificial intelligence, and machine learning as maybe a subset or a simpler view of that? And I'm going to throw a couple of other ones in there, Jen, because I don't even know what all of these mean, honestly. Large language model, I hear LLM and natural language processing. I think I understand that one, right? I've got an Alexa device. I get what natural language processing is, but those, what do those mean, right? And what do they mean to the space we work in?
Well, I mean, machine learning and artificial intelligence, I think particularly when I don't want to keep going back to additive or design for additive, but again, when you're allowing an application to create a model that you're going to produce based on just simple input parameters and loads and things like that, you're actually allowing that machine to design or allowing that application to design. That's the easiest way it fits in with, all the digital manufacturing that we've been talking about. But artificial intelligence goes so much further beyond that. It's a little scary, actually.
It is. I mean, I get scared looking at, this is one we haven't talked about either, but maybe it's related, which is generative, right? The generative design stuff that you can only make with additive, but it's like all these organic shapes, and it's based on the computer, the model, the simulation of forces, those kinds of things. And it's like, hey, if you want to have material where the load paths are on this part, this is where the load paths are. And it looks like, crazy spider webs and I don't even know what. They're crazy organic shapes. But that, is that machine learning? Maybe. I don't know. I don't know if it is. It's probably a different animal. But that idea that the computers are starting to augment us based on data, math, models, science, all those things that sometimes are beyond what we as humans would calculate or predict or create. That's where I think AI gets really interesting in engineering. It scares me a little bit too, because one of the things I hear about AI is that you can't get AI to explain how it arrived at an answer. So you can't have it tell you like, well, because of this and this, therefore this. And a lot of engineering is about basis, design basis, and justification. And, here's what I checked and why. Because it can lead to life, safety, health kinds of issues. And you want to know somebody did their due diligence to make sure they were being careful.
And goes to repeatability too, right?
Right.
If you can't explain how you came to an answer, that goes back to math class.
Right.
Show your work.
Yep. If you can't get there again, do you trust it? Right.
Right. Is it even a good place to be?
Yeah. But I do see that even if that's a little scary and there are things that are concerning, there are lots of places where it could help, right? Can it just augment what we do and then we can double check it, right? One of the applications of AI I've heard about in PLM that I think is very interesting is, well, if it's watching all your change orders and it's looked at the pattern of thousands of change orders you've done on your product over the years, could it chime in on that next change order and say, hey, look, every time you make this kind of change, you normally change the material also. Have you thought about changing the material? Okay, great. If it's asking me questions and reminding me of things I might not have noticed, that sounds good. I'm down with that. It's the, making decisions for me that I don't know how to trust. That worries me.
Well, I do know that there are different CAD applications out there that will basically, based on how you create something, how you create a model, what menus you use, it will change your UI.
Wow.
Based on what you usually use. And it will suggest, if you're doing that, you should do this.
That makes me think of natural language processing too. I would love to just, do CAD by talking to the computer. Hello, computer. Reminds me of Star
Siri,
Trek.
create this for me.
Talking to the mouse. Hello, computer. Hello. But I won't even go deeper on that. I've got another one. I've got another, technology from the future coming back today. And hopefully I'm going to get this right because I'm no expert at it. But extended reality, XR, right? And I think that's the umbrella for virtual reality, augmented reality, mixed reality. I'm probably missing some realities. But, that whole basket, what do you see there? Do you think that's just one of those that's going to go away? Or do you think that's one that we're yet to see what it can really do for us?
I think it's one we have yet to see what it's really going to do for us. I think there's a lot of potential in there. Primarily, you were talking about like if you're out on a aircraft carrier and you need to fix something, you need to print a part, whatever, like you need to replace something. Having, rather than, reading a manual that's in a particular language, rather than just watching pieces, like an exploded assembly, how things go together. But if you can actually view somebody doing it, if you can actually reach into that, you can train people ahead of time by having them work on an augmented reality or a virtual reality scenario. I think it has real potential. I don't think we've even touched on it. I think there's a lot of challenges with it too.
Sure. I love the idea though. I love, I get excited in a lot of ways about PLM and what it can do for people and digital stuff, what it can do because of the time it can save. And I love the opportunities that you just brought up a minute ago. I love the opportunities you just brought up a minute ago related to working on something before it ever physically exists, right? I hear this in the service arena, right? And that's a part of the life cycle we don't talk about a lot. But if you could train your service technicians or your installation technicians on how to do something with a brand new product before you've ever manufactured the first prototype, because you've got a virtual model of it and you could put it in their goggles or headset or whatever and say, look, here's how it goes together. Here's how it comes apart. Here are the steps you need to do. You could even get input from them before you finish the design because they're going to tell you, look, I'm not going to be able to get that screw out. That's, that thing's under there. I can't get my hand in there, that kind of thing. But I really agree with you. There's a lot of opportunity for speeding things up, for having insight, things that we wouldn't ordinarily be able to figure out. And it's like, maybe it's not artificial intelligence. It's human intelligence brought into the virtual world or something. But we can get more insight with tech like this.
Yeah, I mean, another great example would be surgeons, right? Performing surgeries. And this is, again, I don't want to keep bringing it back to additive, but like you can reverse engineer, you can scan someone's femur or scan someone's heart, or like basically use X-ray and MRI data to create an example of, a real life example of a person's heart or lung or eye, and have surgeons actually interact with that in a virtual capacity before they go in and open you up.
I love the idea of my doctor having practice.
And the more the better.
That sounds awesome. All right, I want to come back to one.
Okay.
We talked about it when we talked about smart factory and Industry 4.0 and digital manufacturing a minute ago. But IoT and IIoT, what the heck does that mean? I mean, when you think about it at its base, what are we getting at there?
Data and more data.
Yeah.
Whether it's how you're interacting with something, whether it's how the system itself or the product itself is behaving. IIoT is, more on the shop floor, I think, from a manufacturing standpoint. But just more and more and more data that we're capturing and finding new ways to use that data. I don't think we've even, again, in so many of these areas, right? We haven't touched on the possibilities of what we can do.
There are two things I think we have to say in that breath. And one is I should have started with is defining the word. Maybe we said it earlier, but IoT is Internet of Things. And IIoT is Industrial Internet of Things. And the key word, I believe, because actually when you take Internet of Things and you look at all those words, you're like, what in the world is that supposed to mean? Is sensor.
Right.
Networked sensor. And I think that's where you're coming from when you say data.
Does that not sound nearly as sexy, though?
It's not. It's not as good as IoT. But to me, that's the definition that I think of, or that's the concept that I think of when I think of IoT is I'm putting sensors for all kinds of things. What's the temperature? What's the acceleration? What's the pressure? What's the electrical reading? You name it. All kinds of sensors on stuff and collecting it, networking it together so that I'm getting it real time. I'm getting that data that you just talked about. I'm getting a bunch of it back and I see how it relates together. That's the internet part, right? Is maybe it's coming to me over the internet, but it's networked in some way that I see how it works together. Oh, it's accelerating and the pressure's going down and the temperature's going down. Maybe that means it's going up in altitude. Okay. And I've got GPS. Now I know where it is. Aha. And it's putting all of that sensor data together in a way that turns it into information. We're like, wow, look at that. And the industrial side is just, doing it on the shop floor, like you said. I think that makes perfect sense how that fits into smart factory, the IIoT thing. But what about the IoT piece, right? If we come back to not on the shop floor, but maybe on the product itself, do you think that this one's still early days or it's a fad, or what do you think?
Definitely not a fad, because more and more products are being developed with those capabilities, with those sensors, et cetera. We talked on one of the podcasts recently that I bought my daughter a new car. And, it collects all of the data, and it, as far as her gas consumption, how she drives, how she's using the car, where the car is, if it's locked, if it's unlocked. It collects all of that data constantly, puts it up to a database, and I can access it via my phone.
Tons of sensors, right? Tons of sensors. And it collects it and integrates it all in a way that, like you said, you can see it from your phone. The scary part is then, GM or Ford or whoever it is knows exactly where you are, what you're doing, how you're driving.
Yeah. Very big brother. Yeah. Very big brother.
But good information to have as a product developer, right? So let's not take the cynical view and say, well, instead, it helps me develop a better product when I understand how people are using my product based on being able to track and see what happens to it. And I think IoT, it's still early days in what we're going to see, what the possibilities are. We're seeing some fun ones like, I can unlock my car remotely when I've lost my key or locked my key in it, that kind of thing. And you know what? That one brings us right back to digital twin, by the way. Just saying. I think we have to talk about buzzwords around making more of this stuff real, right? Lots of good concepts we've talked about. But I love one, and it's integrated digital environment. It's IDE, but not what people have thought of as IDE traditionally, right? A lot of people hear it as integrated development environment. Coders and developers say that's what IDE means. But this is coming from I think mostly the defense space, that an integrated digital environment it's like a workshop for doing so many of these things we've talked about already, right? It's the place where you build your models and connect your models together. And the integrated part is it's a bunch of tools that are already pre-chained together, pre-integrated to work together with maybe the models and the data that you need in them. But if I'm Boeing and I'm going to go make the next great fighter aircraft or something like that, I need an IDE. It's my digital workshop for making a virtual twin of that new fighter jet, right? And it's where a lot of these concepts get practical, because you're talking about saying, I need to stand up a computing environment, and I need to put CAD tools on it, and I need these kind of servers and this kind of cloud computing, and I tie that together with this simulation tool and this MBSE tool, and I connect them together in this certain way, and then I create a bunch of instruction manuals and processes for how it all works, and the whole ball of wax, I turn it over and give the keys to an engineer and say, here's your workshop, go make me a digital fighter craft or whatever it is. That, I think IDE is cool.
I think if you marry IDE, which is if you will, the virtual side of product creation, and smart factory, then you've got digital manufacturing.
I like it. Yeah. I think that those concepts have a lot of promise in terms of making some of these buzzwords real and giving us real value and benefit out of them. But it wouldn't be the right way to, thinking of the wrong thing to say here. Trying to think of how to end this to talk about the buzzwords that have died.
Well, not all buzzwords stick with us, right? It'll be interesting to see which of these do, because they don't all live on.
No, they don't. I can think of a few that are from the past that are not with us anymore. Like I remember having big debates, maybe this is 20 years ago, with people, and they're like, do I need a PDM system or a TDM system? And it was a technical data manager, right? And I think that a lot of folks were talking about, well, my drawings, so that goes in a technical data manager. And, I don't do 3D modeling, so I don't need a PDM. And it's like this huge thing, about TDM versus PDM. And I haven't heard of a TDM system, and I don't know how long. Another one like that is big debates over CPDM, collaborative PDM. And, well, do you have PDM or do you have CPDM? And this is maybe even before PLM showed up. But I love words like that you're like, that's not even a discussion anymore.
Well, I mean, it's, your background is much heavier in the PLM space. Mine is heavier on the CAD side of things. So digital mockup, DMU,
right,
was a big, like, nobody talks about digital mockup anymore.
That's right. It's sort of obvious.
It's a piece of everything.
Right. Of course we can do that. But yeah, it was for a while. It was like DMU, that's the big thing. No, I love those. And who knows which of these we talked about today are going to go the way of the cuckoo on that.
Well, and there might be some cannibalism there, right? I mean, maybe we stop talking about digital thread. It becomes passé. It's all digital fabric. Remember when we thought there was just one thread?
Right. No, I think you're right. The big theme here is digital information to help us do things better, enhance our experience somehow, right? I mean, and sometimes that's about like efficiency, saving us work, saving us, using our energy better, like additive, right? Additive manufacturing can be a much more efficient way of working with material and energy and things like that. Or, giving us some new experience like VR. That's definitely a new experience. Or showing us something that we couldn't have understand another way, like when we're talking about generative or AI. I mean, I think all of these things are somehow trying to make our experience better, and using digital tools to do it. Who knows which ones will win.
It's all part of the digital transformation.
That's right. You always put it back under that umbrella, what we started with. So this is fun, Jen. I'm glad we did this. I love taking this tour through Buzzwords. This was a lot of fun.
I think we should do it maybe a year from now and see which ones survived and see what the new ones are.
That's right.
All right. Well, everybody, if you have terms that particularly the old ones, because those are fun, that we didn't mention, or ones that you think we should explore a little bit more, reach out, let us know. Same thing with topics that you want to hear us discuss or questions that you have on any of the podcasts. We'd love to hear from you. And until next time, stay sharp.
Thanks, everybody.